In this video, we'll take one more example of finding HCF of let's say 117 and 45 using Euclid's division lemma. Okay, so let's try this one. So 100, now we have to express 117 in terms of 45. So 117 you divide by 45. So what will this be? 45 2s are 90. If you take 90, 27 is the remainder. Now since the remainder is not 0, now again I have to express divisor in terms of this remainder. So we'll take this divisor here. So we'll write it here. Okay, so 27, 2s are is 54, so it must be 1s are. So 1s are 27. I think 18 is the remainder. Correct. Now again, since the remainder is not 0, you again express 27 in terms of 18. So 18, you bring 27 below down here. In exam, what are you supposed to write? You are supposed to write each and every step. For example, first we expressed 117 in terms of 45. So I'll write them here. So 117 in terms of 45, you wrote it as 117 is equal to 45 into 2 plus 27. 45 into 2 plus 27. So then you expressed 45 in terms of 27 as 45 is equal to 27 into 1 plus 18. Alright. So now you are trying to express this 27 in terms of 18 because the remainder is still not 0. So we'll go ahead and we'll try this one. So 18 2s are is 36. It must be 18 1s are 18. So the remainder is 9. So now we express 27 in terms of 18 like this. So 27 is equal to 18 into 1 plus 9. Now still the remainder is not 0. So you go ahead again express 18 in terms of 9. So bring this 18 here. So it will be 9, 2s are 18, and now the remainder finally became 0. So what did you do here? You expressed 18 in terms of 9. So 18 is equal to 9 into 2 plus 0. So you're supposed to write all these steps. Once the remainder becomes 0, the final divisor itself is the HCF. So therefore, HCF of 117, 45 is 9. I hope you understood this one. So this method is a method of successive division. You don't have to write individually steps by step. You can directly follow this one and write these steps. That is more than sufficient. Let's, for our sake, we'll also try to learn the table method. So we'll start off with 45 and 117, right? So 45 and 117. So you make 3 columns, quotient you write here and the remainder, and you go on dividing. So 45 2s are 90 and the remainder is 27. So you write the quotient here and the remainder here. Now you take these. Now you are supposed, since the remainder is not 0, you are supposed to express 45 in terms of 27. So 27 1s are 27, 18 remained. Now we got 18 and 27. Again express 27 in terms of 18. So 18 1s are 18. So 9 remain. Correct. Now since the remainder is still not 0, we take this 18 and 9. So 9 2s are 18 and the remainder is 0. So once the remainder becomes 0, the previous divisor itself is the HCF. So HCF again is 9. Here also we got HCF as 9. You try your normal method. So normal method of 45 and 117. So let's start off with 3. 3 15s are 45, 3 9s are 20, sorry, 3 3s are 9 and 3 9s are 27. Correct. So 15 and 39. Again you divide by 3, 3 5s are 15, 3 13s are. So 5 and 13 there are no common divisors. So HCF is again 3 into 3, which will be 9. Correct. So this is how we find the HCF using Euclid's division lemma. So in the next video we are going to see how to find the HCF. Furthermore, this HCF can now be expressed in terms of given numbers. So this is what we are going to study in the next exam.